lesson, we took the equation of a circle and used that to draw a graph. In this lesson, we're going to get some information about the circle and then use that information to write an equation. So some of this will look familiar if you were in class on Wednesday, because we already did some of this stuff. But we're just going to go through several examples of the different sorts of things that might come up, because there's kind of a lot of different information you might get, a lot of different situations. We'll try to cover them all, or as many as we can. So the first one, it says write an equation for a circle with a radius of 7 and a center at 2, -3. I did put the equation, the form of the equation for a circle down here in the bottom right. And just a reminder that your center is always h, k. So h and k are the coordinates of the center, and your radius is always r. So on this example, we have all that information. We have the center, we have the radius. We can just plug it into the equation. So we're going to say x minus 2 squared plus y minus -3 squared equals our radius, which is 7 squared. And then I'm just going to clean that up a little bit and rewrite it. I'm going to take that minus and negative and make it just plus. So that becomes y plus 3, and 7 squared, of course, is 49. So that's what you would do there. You end up changing the signs on both of these numbers for the center point, and you square your radius. Next example. Write an equation for a circle with a center at -2, -4, and a point on the circle at -2, 1. So we can start this because we know what's going to go in for h and k, because we have the center. So we have a -2 for h. So if we subtract the -2, that becomes +2. Again, we always change the sign on that number. Same thing with the -4. That's going to end up becoming a +4 because we changed the sign. The trick here is getting the r squared. So we have to figure out what the radius is. And so on this one thing I noticed about these 2 points, the center and the point on the outside of the circle, is they have the same x value. They both have an x value of -2. I'm just going to draw a quick rough graph here. So our x value is -2. The center point is at -4. So it's at 2, -4, -2, -4. And the point on the outside of the circle is at -2, 1. The radius is going to be the distance between those 2 points, between the center and a point on the outside of the circle. So I can tell if this is at +1 and this down here is at -4, I know the distance from +1 to -4 is 1, 2, 3, 4, 5. So I can just look and see, okay, this has a length of 5. So my radius is 5. I square that. 5 squared is 25. Another way you can think of that is you can just subtract your y values. You can take 1 minus -4, and that's going to be 5. And so 5 would be your radius for this circle. Next example, it looks similar to the last one, but it's a little more complicated. It says write an equation for a circle with a center at -4, 2, and the point on the circle at 3, 5. So again, I'm just going to get this started. I'm going to say x, that's -4, so I'll change it to a plus. Got my squared. Y, that's a +2, so it'll be minus. Got my squared again. And again, the one thing I need to find is the radius. And here, I don't have a common x value, nor do I have a common y value. So the way I could do this, there's a couple ways you could do this. You could sketch it out on a graph and do Pythagorean theorem. A squared plus b squared equals c squared. You could also use the old distance formula. So I'm going to use the distance formula. So reminder of distance formula, it's square root of x2 minus x1 squared plus y2 minus y1 squared. So it's your difference of your two x's squared plus the difference of the two y's squared. So my two x's, it's -4 minus 3 squared plus 2 minus 5 squared. And let's go ahead and just keep working this out. -4 minus 3 is -7, so I have -7 squared plus -3 squared. -7 squared is going to be 49. -3 squared is going to be 9. So this ends up giving me the square root of 58. So my radius is the square root of 58. Now I could like figure out approximately what the square root of 58 is. It's 7 point something, but I don't really need to worry about that because to make my equation, all I need to do is take that number and square it. So if I take square root of 58 and square it, the square and the square root cancel out. It's just plain old 58. So that's what's going to go right here. So square roots are actually kind of our friend when we're doing these circle equations. So that's going to be our equation. Our radius squared would end up being 58. All right, continuing here. Okay, we did one of these on the Nearpod as well. Write the equation for a circle that has a diameter with endpoints at -3, 2 and -3, 10. So here we don't have the center or the radius. We have to find both of them. And again, what I'm going to do is I'm going to sketch out a graph because I see I have a common x value. Both of these points have an x value of -3. So 1, 2, 3. And I really didn't need to put the negative side of the graph at all, did I? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have a point at -3, 2, and a point at -3, 10 up here. So this is the diameter of my circle. That's the longest distance across the circle. So I know the midpoint here, halfway between 2 and 10, is going to be my center. So if I want to find the halfway point between 2 and 10, I can just average those. And I find the number that is halfway between 2 and 10 is 6. So make sure I'm in the right spot here. So I have a center point there at -3, 6. All right, I can also look at this and see what my radius is. I know radius is always half of my diameter. It's also the distance from the center point to point on the outside of the circle. And if you look here, if I go from -3, 6 down to -3, 2 or up to -3, 10, either way I go, my distance is going to be 4. So my radius is going to be 4. And my center is going to be -3, 6. And that's all I need. Now I can write the equation. So I've got x, we'll do +3 squared, plus y -6 squared equals 4 squared. So equals 16. So there's that one. All right, here's another diameter with endpoints. And here we don't have a common x value or common y value. So if we were to draw a diagonal between these, or if we were to draw a line between these 2 points to represent the diameter, it would be diagonal. And there's not going to be an easy way just by looking at the graph to figure out its distance and its center point and all that. So here's what I'm going to do. I know that if this is a diameter between these 2 points, the point that is dead in the middle is the center of the circle. The point that's dead in the middle, the midpoint of a diameter, is the center of the circle. So I'm going to use the midpoint formula. And the midpoint formula, you just take the average of the x's, so you add them together and divide by 2. And the average of the y's, you add those together and divide by 2. And if I simplify this, -1 + 5 is 4. So I have 4/2 2 plus 12 is 14. I have 14 over 2. And so my midpoint is 2, 7. So that's my center. My center of my circle now is 2, 7. Now I need to find the radius. And here's what I'm going to do. I know my radius is the distance from the center to the point on the outside of the circle, or to any point on the outside of the circle. So I'm going to take my center, which is 2, 7, and I'm going to take one of these other 2 points. I'll take the 5, 12, just to avoid having to use negative numbers. And I'm going to take those 2 points and do the distance formula to figure out the distance between them. You could also put them on a graph and do Pythagorean theorem. That would work well as well. But I'm going to use the distance formula. So I'm going to do difference of my x's. So I'll do 5 minus 2 squared plus the difference of my y's. So 12 minus 7 squared. I will get 3 squared for the first one and 5 squared for the second one. That's going to give me 9 plus 25, and that's going to give me the square root of 34. So my radius is the square root of 34. So now I have all my information. So let's set this up. So I'm going to have x minus 2 squared plus y minus 7 squared equals, when I square my radius, square root of 34 squared is just going to be a regular old 34, so similar to the one we had earlier. So this is going to be equal to 34. So that's the equation. So a little bit more work, but it involves stuff you've learned before and that you've done before. And that's the thing about all of this. There's not a lot of new stuff here. A lot of it's just forcing you to remember stuff you maybe did 3 or 4 years ago in some cases. So there you go with that one. Let's keep going. This one brings in a vocabulary word, and this gets kind of confusing. And we know tangent is one of our trig functions. So we have sine, cosine, and tangent. Tangent is the opposite over the adjacent, or it's the sine over the cosine. But we also have the word tangent that means, and I'm sure you've encountered this before, it's a straight line that touches a curve at exactly one point and doesn't actually intersect it. So it just kind of grazes it. So that's another definition of the word tangent. And the words actually have a similar origin, and if we have time, I can show you how they're actually related to each other. But for what we're doing here, when we talk about a tangent, we're talking about a line that just grazes a circle at one point. One thing that's important to know is if you do have a tangent line that hits a circle, it will be perpendicular to the radius of the circle at that point where it hits. So this tangent line, if you look at this picture in the lower right, the blue line is a tangent line. It hits the circle at this point, -4, 3. And if you draw a radius from that point into the center of the circle, you'll see that radius is perpendicular to the tangent line. So that's a property that tangent lines have with circles. But here it says write an equation for a circle that has a center at 1, 3 and a tangent line at x equals -4. And here I kind of cheated because we have a picture of the circle. That you could even erase the circle and I think you'd still be able to see what's going on here. We have a center point at 1, 3, and we know this line at x equals -4, and that x equals -4 is the vertical line of all the values where x is -4. So we have that vertical line there, we have our center point, and we know that if we draw a line from the center that is perpendicular to the tangent line, that will be a radius of the circle. So if I go from this point 1, 3 over to the tangent line, I can figure out what my radius is just by counting my number of steps. So it's 1, 2, 3, 4, 5. So my radius is 5. And so now I actually have all the information I need because I already knew the center. The center was 1, 3. So I have x minus 1 squared plus y minus 3 squared equals my radius squared. My radius here is 5, so equals 5 squared. So that's my equation for that one. Let's do another one. And this time we don't have the graph already, so we're going to have to figure this out. We do know the center point. So I'm going to go ahead and set this up with the center point. So we have -2 there, so that's going to become +2. And then we're going to have y -1. And we need to find a radius. So our center is at -2, 1, and we have a line at y = 5. So I'm going to sketch a graph again here. So we got -2, 1. That's our center point right there. The line y = 5. I'm going to go up to 5 on the y-axis. 2, 3, 4, 5. And that'll be a horizontal line where all the y values are 5. So that's my tangent line. So I have a circle that has a center at this point and that will just graze this line. And so what I can do to find my radius is I'm just going to go straight up from my center point until I hit this line. And this little line I just drew is my radius. And so I can just count. I went from, I was at 1, so this is at -2, 1. So I was at 1 and I went up to 5. So the distance here is 4. I went up 4 spots. So that's my radius is 4. So my r squared would be 16. So the tangent line thing, it sounds kind of complicated, but if you sketch it out, it's usually pretty simple. Just draw your center point, figure out where that line is going to be, and then just draw a straight line from the center point up to the tangent or over to the tangent, and you should be able to just really quickly be able to count out how long the radius is from doing that. All right. Okay, now it says, this is a little different. It says, write an equation for a circle that has a center at 4, 5, has a circumference of 2 pi radical 17. And that looks really ugly, but it's not going to be that bad. And again, I'm going to start with the center. Go ahead and get that part done. So I'm going to have x -4. I'm going to have y -5. All right, get my exponents in there. And now I got to figure out the radius using this circumference. So our formula for circumference is 2 times pi times the radius. So we can use that to figure out what our radius is. Because what we can say is 2 pi r is equal to this circumference they give us here, 2 pi radical 17. And this one works out really nicely because you can see you have a 2 pi on both sides. You can divide that out. And what you're left with is r equals the square root of 17. So your radius here is the square root of 17. So then we got r squared. When we square the square root of 17, it just becomes 17. So again, it's just putting together things you've learned before and combining them in new ways. Right, a couple more of these. I know there's a lot of more examples than usual, but like I said, there's a lot of different situations here. Actually, this is the last one. I apologize. So it says, translate the circle represented by this equation, down 3 and 4 to the right. So this actually goes back to the first circle assignment, the one you did earlier this week, where we are going to have to take this whole mess and get it into the correct form. So let me rewrite this first. So we have 16 plus x squared plus y squared minus 8x minus 6y equals 0. What I want to do is I want to get all my x's and y's on one side and get the numbers without x or y on the other side. So I need to move this 16. And I'm going to go ahead and rewrite this so that my x's are together and my y's are together. So I'm going to put the x squared first, then I'm going to do the minus 8x, then I'm going to do the y squared, the minus 6y, and that's equal to negative 16. Okay, so now we got to complete the square. So we got x squared minus 8x and then plus some number that we're going to figure out in a second. And then we'll have y squared minus 6y plus something that we'll figure out in a second equals negative 16. And we got to remember whatever we add on the left, we have to end up adding on the right also. So to find my missing number here, I'm going to take the -8. I'm going to chop it in half. And then I'm going to square it. So half of -8 is -4. -4 squared is 16. So I add 16 there. I'm going to add it to the other side. With my y's, I got a -6. So I'm going to chop it in half, get -3. I'm going to square it and get +9. So I got 9. And I got to add 9 to the other side also. So now I'm going to simplify this a little bit. And that's going to factor down to x - 4 squared. The y one here, the second parentheses, will factor down to y - 3 squared. And then this -16 and +16 cancel out, and I'm just left with 9. So that's my equation. So I've done a lot of work to get there, but I'm not done because I haven't actually answered the question. It says we have to translate this thing down 3 and 4 to the right. So here's what we need to do here. We need to look at what's our center point. Our center point is the point 4, 3. That's our center. That's what we're going to use to translate this. So if our center is at 4, 3, if I need to move that down 3, that's my y value. So if I'm at 4, 3, if I go down 3, that's going to put my y value at 0. So I was at 3, I moved down 3 spots, I'm at 0. 4 to the right. So I'm at 4 originally. I'm moving 4 to the right, so that's 4 in the positive direction. So if I'm at 4 and I go 4 to the right, I'm just going to add 4, and I'm going to end up at 8. So my new center for my new translated circle is going to be at 8, 0. So now what I want to do is I want to rewrite my equation with my new center point. So I'm going to have x - 8 squared plus, you can put y - 0, but you could also just put plain old y squared. The radius didn't change. When you translate something, all its measurements stay the same. It stays the exact same size. So the radius is still going to be 3, and r squared would still be 9. And I'll just, to clean this up, I'll write it with just plain old y squared here, because you really don't need the -0. So that's how you would translate. You need to get your equation in the correct form. You need to identify the center point, and then that's where you're going to do the translation. You're going to go down or up or left or right from that center point by changing its x and y values. You'll find the new center point, and then you plug that into the equation. The radius stays the same. So I know that's a lot of different things, and there's probably going to be a couple that come up that weren't exactly like these examples. But again, it's going to just use stuff you've learned before, just in different combinations. So there you go. There's a bunch of examples of coming up with equations for circles.